Today we have a very interesting panel. I just got to know a couple of experts who joined us. So before you even jump into this, perhaps we'll do a round of introductions since we have 1 hour or more for this panel. I think sufficient time for all of us to speak. So if you could take 3-4 minutes, tell us about yourself and your company and what interests you have in the clean energy or green hydrogen space. Well,
thanks, Nishaanth. So I am Anirban Kundu. I work for Indo-German Energy Forum. So that's a for a high-level political forum started back in 2006 by the two governments, Germany and India. The main objective is to promote green energy transition in both countries. So we basically work in a overarching 4 or 5 subgroup, which is very relevant for energy transition in India. Which is one is flexibilization of the power plant, then renewable energy, energy efficiency, green hydrogen finance, and grid integration. And very recently added is green hydrogen. So, and in Indian side, the jointly 2 German organizations. So one is GIZ, German Technical Cooperation Organization, other the KfW, German Development Bank. Both are implementing on behalf of both governments. So we are from the support office. So I will stop here and
This works? Okay. Well, we don't have very many people here this afternoon, but so I've been involved in the energy businesses, international energy businesses. I'm now into my 6th decade. I started in the 1970s and still hard at it. And we'll talk a little bit later about the progression over those 6 decades, how energy has progressed and how we face the financing challenges through many, many projects over that long period of time. I originally started as a commodity trader in metals and minerals, later moved into crude oil, and have been really an energy guy, hardcore energy guy all my life. So that's my background.
Yeah. Hi, thank you. I am CP Tiwari. I had business development services and technology vertical in generation cluster of Tata Power. Generation cluster is responsible for all coal waste, hydro, pump hydro, and as well as new emerging areas like we are also trying to work something on. We are exploring nuclear energy and then long duration energy storage. And at the same time, we are also trying to provide the RERTC solution for green hydrogen. As far as Tata Power is, I am a mechanical engineer by profession with around 30 years of experience. And I have worked almost all, if you talk, all sort of power generation technologies, starting from coal waste, gas waste, then solar, wind, and whatever you talk in power generation. So I have been working in those sectors. As far as Tata Power is concerned, Tata Power is one of the largest integrated power companies, private power companies in India. We are present in almost in all part of power value chain, starting from initially maybe coal mining, then generation, and we have close to 15 gigawatt generation capacity within India, out of which 9 gigawatt is based on fossil fuel and 6 gigawatt is based on clean energy sources. We are also there in transmission and distribution. We build, own and operate the transmission system in the country, and we also distribute electricity in 4 states, that is in Maharashtra, in Mumbai, then Ajmer, Delhi and Odisha, and we are serving to more than 12.5 million consumer in electricity distribution. So I am very glad and excited to really participate in this panel discussion and see how I can contribute here. Thank you very much.
Thanks. I'm Rajesh Mehta. I work for TNO. We are a Dutch applied research organization based out of the Netherlands. My primary role is to build large consortiums for TNO to bridge the gap between industry and the applied research here. So we bring the technology from the lab scale to a commercial scale, probably at a demonstration level and at a pilot scale level. And then it's a job of the industry to take it forward for maturity and also deployment. So I look forward to working in green hydrogen space, like that's my space, and also the chemical and the plastics circularity. So those are the portfolios under me, and the prime focus for us today is like at this panel is to also understand what's going on in India in the green hydrogen space and also on circularity. And that's my interest to learn from the co-panelists as well. And we actively work on different technology development. So we try to actually take care of the technology risks, what are emerging for the industry, and can we actually reduce risk for them by giving them the right answers which are fact-based. That's the important and independent, because we are an independent research organization. So we are not aligned with anyone in terms of industry or a sector, and the primary objective is always to present the facts with independence, so that the industry and governments can make the right decisions. Because any decision which is at the political level in policy making or at the sectoral level, such as industry associations, when they take positions, it has long-term implications. And how do you actually reduce those risks for all of these stakeholders is part of our role as well as a research organization.
Wonderful, Rajesh. Thank you very much. And thanks to all of you all. I think this is a very diverse panel. You have two people doing projects, one doing financing, one doing research. And, you've stuck to your time. You have 2-3 minutes each. Well done. And I think we have 40 minutes more. But before I get started with the questions, just a little bit about GH2 India. Mr. Jyotilal promised to be here. I don't see him anywhere. So if he's here, that'll be great. Okay, Mr. Narain is here. Good. So GH2 India is India's most active green hydrogen network. We work with governments across the country, regional and the central, helping promote green hydrogen policies, capacity building in the states, but we also support companies in their ambitions. We handle some of the international issues and challenges that India is facing. Now, just to give some context on green hydrogen in India, India is one of the few parts of the world where the government's targets were exceeded by industry announcements, right? And we take this for granted. Nowhere else in the world where, governments set certain targets and the announcements exceeded it. So in India, 5 million tons was the government's target, and we have close to 7.6 million tons of green hydrogen capacities announced by some of the large developers here. We've tracked close to between 90 and 100 projects in India, and the largest green ammonia project that will come online will be in 2027. But in the last 2 years, what has happened? Several pilots and projects have been undertaken, and this is a learning and evolving space for all of us, because every month there is a lot of surprises coming in. Today, 2 years ago, the price of green hydrogen, as people claimed, was at $5-6. And today, if you ask some of the large developers that are looking at vertical integration, they will tell you we can do it below $4. But there is no consensus. It hasn't been established yet, right? So therefore, every month, every quarter, we are evolving and learning more. So what has happened in India so far? Last year, our current capacities of green hydrogen is 3,000 tons of green hydrogen a year. And just to give you some parallels, China is close to 100,000 tons already, right? So, but is India doing very poorly at 3,000 tons? No, we are in the top 3-4 countries in the world at 3,000 tons, but our goal is 5 million tons. And what sectors have these pilots and demonstrations taken place in India? That's also a key thing to look at, because when the mission was conceived, everybody thought refineries is the low-hanging fruit. You put green hydrogen, you blending at 5%, 6%, you would end up at 2 to 3 rupees appreciation in the price at the petrol pump. But what has happened now? Mobility has been taking off, right? And Kerala is a good example. You have hydrogen buses, you have the hydrogen metro, you have blending as well taking place across India. And some of the other niche applications of green hydrogen has been in aluminum making, optic fiber cable making, and also in stainless steel making, right? And of course, the steel pilots are underway, and I think Anirban and KFW are also supporting some of those steel pilots in India. There's also several other niche applications being looked at, and hydrogen for power is already being done in the Himalayas and in other parts, but we're very far from large scale production of green hydrogen. So why do we need green hydrogen? We need green hydrogen because it is the only solution in the hard to abate sectors, and across all the hard to abate sectors, including refineries and fertilizers, heavy mobility, aviation, shipping. Green hydrogen is the only solution to almost 20% of the world's carbon emissions. So that's why we're doing green hydrogen. So I hope that set the context, but let's look at the challenges, right? It's so important, but why aren't we making green hydrogen in tons? So I want to, perhaps I'll bring Frederick in first, because Frederick, you have some experience in the commodity markets. You've been in the LNG business. Now you're looking at nuclear as well. How do you think green hydrogen can be commercialized and scaled? What are the challenges in your eyes, and how do we address them?
Well, I think this is an excellent question. Before I start to answer, I just want to thank the Kerala government for the invitation to attend this conference. And I think they really invited me because I'm probably the oldest person that they could find who knew the most about the energy business over decades. And so I'm going to talk for a few minutes and give you some examples, not from hydrogen, but from what we learned in earlier experiences. Basically, my career started with the crude oil. That was basically, let's say, 1970 through to the year 2000. Then I transited into gas, which really started in 1990 through 2020. And then now we're into a new era, which is the renewables era. So what did I learn from going through those transitions where we had a new business project, how to finance it, how to make it a reality, a global reality, a large global reality. Now, the first building block was the crude oil experience. This was probably the easiest challenge because starting around the 1900, the international crude oil business began to grow. And we had tankers that moved crude oil around. We have tank farms where the crude oil was stored. But one thing we didn't have was the spot trading of crude. Traditionally, the crude oil business was a business by the oil majors or the national oil companies. And what happened was in 1973, as I said, I was a commodity trader in physical commodities, and we decided that we would start trading crude oil. So how do you trade crude oil? How do you finance it? And the answer is really you get the customer to finance it. If unless you have an excess of equity, most of us don't or didn't in those days. So really it was a question of customer financing, and we relied upon the credit worthiness of the oil majors to finance all of these trades. Moving into the second phase, away from crude oil, now moving into gas, particularly LNG. Very similar story. LNG was traditionally a state oil company enterprise. However, some private companies started to get involved in it. And my partner and I, business partner and I, we decided that we would get involved as private people. So it's a very steep hill to climb. LNG, you cannot imagine a more capital-intensive business than LNG. The liquefaction plants, if you do a 10 million ton liquefaction plant, that's $10 billion. Then you have the ships. Each ship is $250 million. You probably need 8 ships for a $10 million project. Then at the other end, you have a regasification project, which is another $1 billion. So the billions and billions of dollars very, very quickly add up. And the only way to, again, unless you have the equity, if you don't have all of the equity, if you don't have the multi-billion dollars, you need to have a customer that will help you to finance. And I think that's probably where we're at with our green hydrogen business. We would like to expand our interest in this business, but I think we're going to have to find that the customers will help us to finance the business. So I would very much say to everybody here in the room, just think about that. The one thing that didn't change through over those 50 plus years was really customer. Customer is absolutely key. So I'll pause at that point and let somebody else make some comments.
Frederick, thank you very much. I think you drew very interesting parallels, and several of us in this sector, we need to understand that because it's very unique where we are positioned. We're talking about an industry that does not exist pretty much, but all governments have policies, targets, and subsidies, right? That's the interesting space we are in.
Yeah, in each case, the industry did not exist. It was just an idea. So how do you make it a real reality? And if we have time, I'll come back to talk a little bit more about the LNG business because it's really a very interesting story. But let's please move ahead.
No, I'll definitely bring you back in. Maybe before that, if you could let Mr. Bhavesh from Kirloskar. So if you could, say a few words about yourself and what you are doing in the green hydrogen space, please.
Yeah, myself, Bhavesh Kansara. I'm from Kirloskar Brothers Limited. I'm heading the division for the power. This includes thermal, nuclear, and hydro. And when we speak about green hydrogen, what I want to add in, where our subject is on the commercializing and investment in green hydrogen. So hydrogen processes, we are not directly known as hydrogen process, but the green part, that is the renewable part, the supporting energy source, that is solar and I would say wind and especially the hydro. So we have identified so many opportunities, because many of the hydro spots are in clusters. Everywhere you don't have a big waterfall or major things where you can put up the big hydro power plants. But we have identified after the survey, we have identified so many spots for a hydrogen OEM who need a renewable energy as a key product to make it a green hydrogen. Unless you don't get a renewable energy to make it, it's not a green hydrogen. So these sources where they are in clusters, they can put up small units and they can do the net metering and get those energy involved in production of their hydrogen and finally get it a real product for that. So we have been commercializing to an extent that we are bringing the solutions as well as we are supporting guidelines to the policy also existing which are there. And in existing infrastructure, how can you put up your hydro plants? You don't have to put a hydro plant for that. In your existing processes, you can put these machines like a bypass to a PRV valve or a machine which can be put up in a supply water line where excess pressures is there. So those all energies can be utilized in generating the green power. And this power can be utilized further through net metering and all. OEM can utilize those and generate the hydrogen with this. So that's an initiative we are supporting.
Thank you. Thank you for that introduction. But maybe if I can move to Mr. C.P. Tiwari from Tata. Let's keep this theme on, how do we scale green hydrogen? What are the challenges you see and how do you face them? And I know as Tata, you are across different verticals. You can produce the green electricity, you can produce the green hydrogen, but you can also consume it in various aspects of your conglomerate. So as the Tata Group, how are you viewing the opportunity in green hydrogen? What steps are you taking to address some of these challenges that exist? And if you could share a little bit about your contributions to the space.
Yeah, thank you. I'll start from where my co-panelist has left. Definitely, consumer is one of very important stakeholder in entire green hydrogen value chain, and we need to have consumer who can consume green hydrogen. And we are having consumer who are consuming hydrogen, but they are not able to consume green hydrogen. And the biggest barrier for use of green hydrogen is the cost of green hydrogen itself. If I'll go with more detail on cost of green hydrogen, then we see that in hydrogen, 70% cost is cost of RE, and then balance maybe 60 to 70 is RE, and then balance is the capex of green hydrogen generation plant. So what is happening that we are telling that scale is not there, and that is one reason why we are not able to get the competitive cost of hydrogen. Having said that, the major barrier is that how we can get the cheapest electricity for hydrogen generation, and that's what we are trying to do. In fact, when we talk about electricity, everybody's minds solar and wind energy come, which is available at lower cost. But the challenge is that we are not able to use that energy for operating my electrolyzer round the clock. So now the question is how we can convert this intermittent energy into round the clock energy. That is the biggest challenge, and that challenge can be solved by energy storage solution. There are energy storage solution. People are claiming that battery costs are going down. But when we try to compare the storage cost, then we have to also see that when we are comparing storage cost, then whether it is a single cycle or 2-cycle discharge. Because what is happening that you are getting a low cost electricity during solar hour, and whatever energy storage solution you need for this type of industry like green hydrogen, you need long duration energy storage wherein you can store 6 hour, 8 hour or 9 hour energy, and then you can discharge during non-solar hours so that you can maximize the operation of your electrolyzer. So obviously, we expect that some more disruption to take place in long duration energy storage solution to make hydrogen competitive. At the same time, on electrolyzer side, we also expect that there should be some disruption in terms of improving the efficiency itself. So that presently, say, we are consuming 55-56 unit of electricity for producing 1 kg of hydrogen. How we can bring down to say 42-43 unit of electricity. So that type of innovation is required. And finally, what type of innovation? Some innovation may be required on electrolyzer itself, so that we can reduce the cost of electrolyzer, we can improve the life of stack, and finally we can improve the efficiency and reduce the cost of hydrogen. So these are some barriers, and we at Tata Power are working on providing the green energy solution for hydrogen generation plant also, and we are actively working on some of these aspects. Thank you.
No, Mr. Tiwari, I want to, I'm glad you brought up long duration energy storage. It's going to be a very critical component. But today, if you could enlighten all of us, compared to, using a traditional BESS platform versus LDES, right? What are the cost benefits? Is LDES actually cheaper today? Number one. And to follow that question up with, what kind of LDES technologies are you looking at?
Yeah. So if you'll talk about long duration energy storage, because what is happening that presently we are trying to compare with 4 hour or 2 hour or 4 hour storage. But if you are going for say 6 hour, 8 hour or 9 hour storage duration, then definitely long duration energy storage solution will also be competitive with battery energy storage. And as far as maturity level is concerned, already in country lot of companies are working on pump hydro storage solution, which is also a sort of long duration energy storage, wherein we are trying to store 6 to 8 hour, or maybe if we are able to do the charging of system twice in a day, then we can even do the discharge for 8 hour, 9 hour also. So on those, if you are able to maximize the discharge cycle of long duration energy storage solution, then that will be competitive with battery also. But if you see the present grid requirement, maybe grid is not requiring long duration, and we are able to manage with short duration energy storage, and that's why we are finding is difficulty in comparing the cost of long duration with short duration.
Thank you very much. If I can move to Anirban. Anirban, this is another industry that requires a lot of government support, and DFIs and government agencies will have to play a key role. Where do you think, you can support this ecosystem in India? How do you help with scale? And if you could also highlight some of the programs that the government of Germany and KfW is running to enable this.
Only to the battery storage or overall?
So overall for green hydrogen. Okay. We let's move away from battery storage, but to green hydrogen and,
Thank you very much. And first of all, I would like to thank the Kerala government to giving us an opportunity to be here, and we are very much privileged. The Indo-German Energy Forum, we're very much privileged to work with the dynamic leadership of Mr. Jyotilal sir and entire ANAR team to a very, what I call it, it's very one forerunner project, very closely working with them for developing Kochi Green Hydrogen Hub, which is probably among the top 12 or top 15 in the world. And so just to mention that my colleague were very much involved, Kumar, so he made so many presentations when we started with the program. So everyone, be it financer, DFIs, everybody are asking them to, like, what you are doing, what is the plan. So to start with, we are in a very good place to talk about green hydrogen. Now coming back to the German engagement in the RE space, including green hydrogen. Germany is very long time with India as an official German development cooperation in technical as well as financial. And the technical cooperation has been implemented by GIZ. So, and in these, all those cooperation as a renewable energy forms one of the major pillar out of other pillar. And GIZ in GIZ under the technical cooperation working in all aspects, like starting from the solar, battery storage, to agri-photovoltaic, to every areas of the renewable energy, including green hydrogen. And there is another, the pillar of German cooperation is German financial cooperation, which is implemented by German Development Bank, KfW. So they are, for a long time, they are involved in India in terms of investing projects in renewable energy, not only financing, but also bringing the finance plus element, means the German expertise, or also the international expertise, as well as helping partner to prepare bankable projects and sustainable projects. So KfW also involved in the solar, green energy corridor. There's a very signature project, and also different storage facility, energy efficiency, and they already, my colleague in some other session already indicated the volume, but again, I'm repeating that. So total volume around more than 6 billion, including which already been financed and under the portfolio, and some are in the pipeline. So this is the official German cooperation, the development cooperation. And then comes in the Indo-German Energy Forum. It started in 2006 started with a very kind of the agreement between the heads of both countries, that both countries agreed to work together for promotion of green energy transition in both countries. And then they agreed for 5 vertical they will work: the flexibilization, renewable energy, energy efficiency, green energy finance, and the green hydrogen is the new things. These are the area. Now, in 2022, Germany and India also agreed to set up a Indo-German Green Energy Task Force with an objective to prepare Indo-German Green Energy Roadmap. Now, this is very important in green hydrogen space because both countries agreed, and the roadmap is now already launched. And roadmap identified many areas, out of which I will take few of them, to identification of the investment opportunities. So both countries agreed to work together to promote green hydrogen in the hard-to-abate industries like steel, fertilizer, shipping, aviation. So those are the area, and long-distance transportations. And then they agreed to promote the refueling stations, also promoting the green hydrogen hubs in India. So Kochi is the start with, and also they are working in Ramagundam, many other places. Then another pillar, they agreed for selecting the appropriate investment models for finance green hydrogen. So already there are some models they are working with. One is the PTX Development Fund, which is implemented by German Development Bank, KfW. So India is one of the selected country under the fund. The idea of the fund, that the project which gets selected, and important thing is that it could be a public sector project or private sector project. So they will get up to 30 million euro grant grant as viability gap funding. So they're also very important. Like there are certain fund, although not internationally available, domestically, like a European green hydrogen. Sorry. No, European, but this fund, once the project is selected to receive the money from the PTX Development Fund, the fund will be disbursed during the financial closure time. Similar type of fund established in Europe, it is more on the production starting stage. So you getting this money as an upfront grant during the financial closure, that will help you to raise finances much effectively. This is one established format. Then we from Germany also has that's a hydrogen ramp up program. That's more of a soft support. It's also implemented in a public-private partnership basis. German government is giving some grant, and the private sector companies are topping up with a matching grant to prepare project, because you need to have some money to prepare a bankable, sustainable project. So that is also ongoing. In addition to that, just I'll very quickly wrap up that another thing which already started is a H2 Global and HINCO, where that's the first time ever in the green hydrogen space that's looked after funding in the demand side, because so far all the available fund are primarily supply side fund, be it Indian government support fund or any other fund. So that's the one tender already like been then. Now they're going for the second tender. So basically the idea is to have a kind of the HINCO is under the wholly owned subsidiary of the H2 Global. It's basically from support from the German government. So they are basically purchasing the green hydrogen from developer, and then they will have the sale agreement to the off-takers. And the difference between the production cost and the selling price, that will be supported by a grant fund from German government. So that will really get a real good boost up to the market, and also in the process that will able to kind of a good mechanism for price discovery. So this, would you like to?
Wonderful.
Very quickly, I will wrap up other areas. These are the two areas of the Indo-German green hydrogen roadmap. Other than that, also both countries agreed to also have a foster the market, to have a trading platform, to set up a hydrogen trading platform in Germany, European Union, and similar thing like in India. And also kind of a tie-up between both countries for research and development, and then technology transfers, off-taker transfer, public-private promotion of public-private partnership, because that's also important for a knowledge transfer one. Then the matchmaking means the producer and off-taker meeting. So those are the areas now both countries are moving forward and taking to the implementation stage. I'll stop here.
Wonderful. Thanks very much, Anirban. I think you highlighted some of the key aspects that governments need to take to enable something like this. The CFD mechanisms from HINCO and H2 Global and the H2 Up program and the PTX fund are all great examples. And I hope, other governments can draw inspiration from that and build their own H2 Up programs and their PTX funds, because the industry really does need it. But Mr. Tiwari mentioned two things, which is on optimizing efficiency in the electrolyzers and then bringing the cost of the electrolyzers down. So Rajesh, if I can come to you, you are working with materials and everything in this space. It's very vital, because even though it's only 30% of the capex, in the opex part, the electrolyzers efficiencies, if it can come down, will make a significant difference in the cost of green hydrogen. So with you and your organization, what efforts have you been taking in this space?
I'm glad that you asked that question. So yeah, we are actively working on next generation technologies on electrolyzers specifically. So the entire portfolio of technology is on the table for us. So we investigate PEM, AEM, and also solid oxide electrolyzers, and fine-tuned for different use cases. And the entire effort is, of course, to lower down the cost and also bring in reliability aspect for the technologies at hand. Because operational flexibility is still a challenge for the industry, because the end users want to operate the plant for 8,000 hours a year. But from the grid point of view, flexibility gives them an option of actually utilizing the lowest cost of renewable electricity. So there is a big mismatch in those. And this also has an implication in terms of downstream derivatives of hydrogen. So if you run your electrolyzer intermittently, your chemical industry will not take that hydrogen because they want to run their separation units, they want to run their reactors downstream continuously for 8,000 hours. So they do not like to shut off the plant. There is a lot of off-spec material there. So to address those, so I'll go back to the technology piece. We are specifically investigating in how we can actually improve the PEM electrolyzers. It's not only about the efficiency aspect, it is also about the reliability of the supply chains. Because there are a lot of critical raw materials which go into making these electrolyzers. How can you reduce it to take care of the supply side risk associated with it? For example, iridium. We have worked on iridium technology to reduce 200 times the utilization of iridium from the existing PEM electrolyzers. Now, if the existing technology, not TNOs, but what is in the market is about to be applied for the ambitions we have for green hydrogen, only for Europe, this exceeds the total supply of the global iridium by 2030. So there is a big mismatch between ambition versus supply side of the critical raw materials. So we are investigating those choke points from the supply side, and can we actually tune in the innovation? That goes back to my initial statement on reducing risks for the technology development. So how, as a technology developers, you can work towards reducing the technology risk by developing on the technology which will deliver in the long term. The other aspect is also reducing the risk for the industry, which do not want to be logged into a technology which nobody is going to utilize in the future. Like everyone is scared to put a first of its kind plant because the second and the third plant is going to be more operationally beneficial. And how do you avoid being a marginal player in the market?
Rajesh, I have two questions for you directly, right, if you don't mind. Now, one is, can you replace some of these rare earth metals in the PEM? Are you working towards that? Or are you just trying to improve efficiencies?
So we are trying to actually first is reduce this from an order of magnitude. So I mentioned about
quantity of
the catalyst being used. Then there are also technologies being investigated, such as solid oxide, which actually eliminates the use for raw materials. And then there are also membraneless technologies, which are actively being, but those are really early stage technologies.
Yeah. No, we've seen some of them come out of India as well, the membraneless technologies. But my next question to you, perhaps Anirban will take comfort in this as well, because someone who's trying to finance these technologies, they don't have operating data. They see a lot of risks, right? How can you provide some comfort to them? And also, follow up to Anirban, what can you do in terms of providing guarantees towards something like this at early stages?
So we work across platforms. When I say platforms, these are various business models for the industry, because industry wants to reduce their risk from the technology development point of view. So one of the options is shared research programs, which we actively work on, such as large European projects or a government-to-government project, such as Government of India or European ones. I have not worked specifically on those, but European ones, personally, I have a lot of experience and I specialize in those. And big companies come forward, small players as well, and then we reduce the risk for them on the technologies, which they do not want to do in-house. They want to work with the research organizations such as, so we develop it and we pass it on to the consortium to take it forward. That's one business model. The other one is companies do not want to have large R&D programs for each and every technology which is under the sun. So we work on B2B projects as well to give them an answer whether this would be a winner for them. So this way, they reduce their R&D cost and also accelerate their R&D cycle to deploy a technology faster in the market. So these are a couple of examples on the options we have.
Thanks very much, Rajesh. You're doing very important work in this space. Anirban? Guarantee mechanisms, what MECA can do, and if KFW can also do that.
That's a very important thing. Like that's among other supply side investment, demand side investment, there should be some kind of a guarantee mechanism. So I am not much aware specifically in the hydrogen space, any guarantee mechanism exists for any of the KFW product in India, but that's required. And what only even I don't also not much aware of any DFIs has any guarantee mechanism yet in India. Only thing I no, now I don't see Survi from World Bank in this room, because in Chile I heard that they have developed.
I was going to mention that to you.
In Chile they have developed one guarantee finance, the World Bank with a Chilean the authority. So that could be another thing, but India, that's also very much required, especially the sunrise sector like that.
No, I think that is the only example today. After 5 years,
everybody talks about Chile. Yeah,
after 5 years of talking about having guarantee mechanisms for, to mitigate technology risk in green hydrogen, there's been only one. And that is something I think, your colleagues and other DFIs should look at seriously.
Absolutely, they are looking into it. But there is also another thing specifically for India, many of you already know, which we came to know in December last year. I'm sure now it's already in practice. The Ministry of MNRE has approached the Ministry of Renewable Energy, the main anchoring ministry for green hydrogen project. They have approached the Department of Economic Affairs to change the status of hydrogen. Till that was under this classification of the renewable energy. So now they have approached for change the classification to the infrastructure. So more you put that infrastructure category, then more ECA money can come in, and also that can also be approach the ECA guarantee from the Export Promotion Board for the export guarantee as well. So that is one thing, but specifically for the technology guarantee, I am not aware anything in it, but that's very much important. Thank you.
No, I think we also need to reclassify hydrogen into a priority lending sector as well, right? So you have better financing terms.
Once you infrastructure, they need to.
I hope Mr. Jyotilal is taking notes of what we're speaking, because I see him writing sincerely.
Things. I don't know whether already that received, but last we know in December they have approached for the cabinet to this thing.
Yeah, we could have a Kerala H2 Up fund and a Kerala PTX fund as well, because there has been a lot that's happening in the state. You have so many of the early stage pilots and demonstrations in the state.
For KFW, Kerala is a very favorable state. They started long ago with a water metro. Same person was there when the KFW started with water metro in a different hat. And also now they are very much keen to take it forward with Kerala.
We have 6 more minutes. I want to, finish the panel with Frederick and Mr. Tiwari. But Bhavesh, since you joined us a little late, but you spoke about Kirloskar, you're across the space. You're in the power sector, not in the chemicals, right? How do you view yourself transitioning? Because your story is similar to every other hydrogen developer in India, right? A lot of them here in India are green energy developers who are making the shift. And they are facing hurdles and challenges. And someone like Frederick and others from the chemicals and LNG space, they will be like, you don't understand the space, right? So how are you trying to learn and how are you trying to adapt?
Yes, good point you raised here. See, basically, we being the equipment manufacturer or like on the renewable side also, we are doing a lot of things in nuclear. But especially in the LNG sector and also coming to this hydrogen now, you will have the processes, right, to make the hydrogen, but then there is another system which is required to make the hydrogen cell. You need a compressed system where a very niche requirement of cryogenic system like cryogenic pumps are there, which is most critical in the whole process. And today I was talking to some of the OEMs who are into this hydrogen cell, and he identified that you make so many pumps, so won't you do some cryogenic pumps which works on minus 250 degrees centigrade? Now, since we have our own organization overseas, we have taken a company in Netherlands also who makes this. So after learning and hearing to this, we feel like we need to time to bring it in India. So we'll try to see that we make a better infrastructure so the companies who are into engage in manufacturing of the systems and also to some LNG carriers, these pumps are available here in India, because today there is absolutely nobody who makes them. So we'll take that initiative forward and see how we can help into this.
It's very encouraging to hear as well, because today when anyone talks about transporting hydrogen in liquid IF form, it's not commercially viable. Let's not even talk about it. Let's all go to ammonia. Yeah. But finally, before we finish this off, back to you, Frederick. I know you had some comments from your first intervention to complete, but also I think, it's people like you having this experience across the commodity space coming to green hydrogen that is really important. I want to also share something else, which is another leading company in India, a big family, one of the top 5 conglomerates in India, without naming them. Their CEO told me, Nish, everybody in the green hydrogen sector today, they have no understanding about it, right? And they are announcing 1 gigawatt size green ammonia projects without knowing the complexity of it. And the second thing, the market is not there, right? Now, what is your advice to all of them? How do we enable that market? And how do we actually, start making 5, 10, 15 million tons of green ammonia out of India?
Okay, so I definitely come to this whole topic from a different angle. I'm a private businessman. I'm here to make profit and create successful businesses. So I'm going to tell you a little story. It's a true story, and not many people know about it. But somewhere here in this room, I hope, is the answer to India's green hydrogen business initiative. So here's the story. As you probably all know, today, the United States of America produces more LNG than Qatar, more LNG than Australia, biggest producer of LNG. I'm not an American. I'm just telling you this is what the Americans have done. How did they do it? How did they manage that? Remember, the LNG business started late 1950s. It was primarily a international state petroleum company business. So any state producer would develop an LNG project. Many billions of dollars required for these projects. How did the United States manage to go from zero to where they are today? And they managed it because somewhere in this room, there is a man or a woman who is similar to the man in the United States who was responsible for transforming this business. This man was a restaurant owner. He owned 5 restaurants in Los Angeles. No background in the energy business at all. But he had the idea that the United States could produce natural gas, could liquefy it, and could push it around the world. And today, as I said, they're now the biggest producer. So to push your green hydrogen industry, we need to find somewhere in this room the restaurateur, the top marketing person, because as I said before, customer is key. Everything is really controlled by the customer. And what does a restaurant owner do? A restaurant owner asks you, is the table okay? Is the food all right? Is the seat comfortable? He looks after you. And that's what this man did in the energy business. He looked after the customer. So that's my message to you. Maybe I'm overly biased about looking after the customer. But if you don't do that, I don't see how you can develop a really large-scale global business.
Frederick, one last thing, the role of nuclear energy in green hydrogen and green ammonia. Not many of us talk about it because very few people are in the space. You're one of those unique individuals in the space. So maybe a quick 1 minute on that.
Yes, I mean, my life...
Sorry, Frederick, before that, more importantly, it's 70% of the cost. So is nuclear energy going to be cheaper?
Yes. So as I said, I started in oil, moved into gas, LNG, and now working on renewables, if you define nuclear as renewable. My business partner and I have one thing we very much believe in, and that's distributed energy. So we're focused on the smaller modular reactors, that is to say something up to about 300 megawatts. And we believe that there's tremendous scale in India and the globe, actually, for this. So that's where we're putting a lot of effort.
And how much land would you need for a 300 megawatt?
Very little land. This is one of the big advantages. You don't need 1,000 acres. You can do these projects 50 to 80 acres.
Very good. So Tiwari, back to you now. This might be the last intervention, but You've raised some very key points on bringing costs, cutting costs. Frederick has brought in the nuclear perspective. Now, as a group, Tata, other companies in India, Reliance, Kirloskar also spoke about it. Everybody is leaning towards nuclear after the government made some interventions, right? What are your perspectives on it?
Yeah, we are, as you know, our MD has already told in media also. So we are really waiting for government legislative changes, because presently, if you see the Atomic Energy Act, so as per present Atomic Energy Act, private developer cannot build and own and operate nuclear power plant. So in last finance budget, Honorable Finance Minister Nirmala Sitharaman has already announced that Government of India is going to amend the Atomic Energy Act, so that private players can also participate in nuclear energy program. This is one hurdle what Government of India is trying to solve. Another hurdle is related to civil liability for nuclear damage. So if you see the civil liability for nuclear damage, which is applicable in India, because of that act, we cannot source the technology from whatever SMR he is developing. I cannot take their SMR to the India, because in that there is unlimited liability on equipment OEM also. Suppose if there is any accident, if any accident happens, then in that case, if I am operator of nuclear power plant, I can sue to him also for unlimited liability. And that's why you must have seen that whatever project are planned with the French companies like EDF and Westinghouse, in India 2 projects are planned, but those projects are not moving well, because the one main reason is they require the amendment into the CL&D Act also, civil liability for nuclear damage also. So as a Tata Power, we are also waiting how government is going to amend these act, and as soon as policy and legislative framework is available for participation of private sector in nuclear, definitely we will also work, and we are already working in this area and trying to identify the site for nuclear power plant.
Wonderful. I think just to summarize, green hydrogen will be here to stay. We are in very early stages. A lot of innovations are happening, within the companies. Financiers are also taking their best efforts. Research institutions are also doing their best. A lot of amendments and policies are required. But even though it's been dark clouds looming over the industry, and I've seen this in the last 3 years as we were looking at project announcements 3 years ago, and then when you start tracking what's been happening on ground, it's been very, very disappointing. But if you ask why all of these companies are putting their money in, it's because it will happen, right? It's a matter of all of us coming together collectively and taking efforts to enable this. So with that, I want to thank all my panelists for all the expert opinions and remarks they've given, and the audience for being a great group. So a round of applause for all the panelists here, please. Thank you.